Hello everyone, I am Abhijit Lal, Assistant Professor, Department of EEE, BIT Durg. Today we will continue the applications of AC machines. In the last class, we have studied about the applications of three-phase AC machines, that is three-phase synchronous generator, three-phase synchronous motor, three-phase induction motor and three-phase induction generator. In this lecture, we will cover the applications of all single-phase AC machines, that is single-phase induction machine and single-phase synchronous machine. So these are the contents which covers the introduction, the types of single-phase AC machines and their applications. So this chart shows the different types of single-phase AC machines. So broadly we can see that the single-phase AC motors are divided into three types, that is induction motors, commutator motors and synchronous motors. Now single-phase induction motors are of three types, that is split-phase induction motor, shaded pole induction motor and repulsion start induction motor. Now under the concept of split phase, we have four different kind of motors, that is resistance start motor, capacitor start motor, permanent capacitor start motor and capacitor start capacitor run motor. Now the commutator motors are of three types, that is AC series motor, universal motor and repulsion type motor. Repulsion type are of two types, that is repulsion start induction run and repulsion induction motor. And lastly, the synchronous motors, that is the single phase synchronous motors are of two types, that is reluctance motor and hysteresis motor. Apart from this, we will also discuss the stepper motors and the servo motors. So let's start with the application of single phase induction motor. In this, first we will see the split phase or the resistance start induction motor. A split phase induction motor consists of a single phase power supply and a stator winding split into two parts, the main winding and auxiliary winding. The main winding is made of thick copper wire having low resistance and high inductance. The auxiliary winding consists of thinner copper wire having higher resistance as compared to the main winding. In a split phase induction motor, the two stator windings are mutually displaced by 90 degrees electrically. The current in the auxiliary winding leads the current in the main winding by 30 degree to 50 degree. So this phase difference is sufficient to develop a rotating magnetic field inside the motor, which in turn helps in producing torque for starting the motor. So this figure shows the circuit diagram of a single phase split phase motor, induction motor of resistance start type. In this we can say that a main winding and an auxiliary winding is connected and a switch is provided, and this is a special kind of switch known as centrifugal switch. So the work of the centrifugal switch is that as soon as the rotor achieves its rated speed, the auxiliary winding is disconnected from the main winding, and during running condition only main winding is connected in the stator. And second figure is the actual picture of the resistance type split phase induction motor. The characteristics of split phase induction motors are: first, the starting current. The starting current of a split phase motor is approximately 7 to 8 times the full load current. The starting torque is about 1.5 times the full load torque, and the maximum or pull out torque is roughly 2.5 times the full load torque and occurs at about 75% of the synchronous speed. The split phase induction motors are relatively inexpensive, making them popular in the market. The application suitability. So these motors are ideal for applications with short starting periods. The high resistance in the starting winding causes it to heat up quickly. If the starting period exceeds 5 seconds, the starting winding may overheat and burn out unless protected by a thermal relay. The power rating of split phase induction motors ranges between 60 watt to 250 watt. Now let us discuss the applications of split phase resistance type or split phase resistance start induction motor. Household appliances like fans, table fans, exhaust fans, mixer or grinders, etc. uses this type of motors. The portable power tools like drillers or grinders, etc., where no load starting is essential. It is used in small machine shop equipment like lathes, drill presses, saws, etc. This type of motors are used in cooling towers and centrifugal pumps handling cold water. They are used with conveyors and elevators with small starting torque requirements. This type of motors are used for small blowers and compressors which require an economical single phase induction motor. Next is the split phase capacitor start induction motor. A capacitor start induction motor is a type of single phase induction motor that uses a capacitor to generate a rotating magnetic field and produce torque for starting. It consists of a stator with two sets of windings placed 90 electrical degrees apart, the main winding and auxiliary or starting winding. A capacitor is connected in series with the starting winding. This shifts the phase of the starting winding current relative to the main winding current, enabling the development of a rotating magnetic field. So this figure shows the diagram of the capacitor start motor. In this, the main winding is connected with an auxiliary winding and a capacitor is connected along with that. And next figure shows the actual picture of the capacitor start motor. Here we can see a capacitor connected to the motor. The characteristics of capacitor start induction motors are the high starting torque, that is, this is the primary advantage making the motor suitable for heavy load applications. It is having single phase operation, that is suitable for applications where three phase power is not available. It is having simple design, that is the robust and straightforward construction leading to high reliability. It requires minimal maintenance compared to other type of motors. It is having moderate starting current, that is despite high starting torque, the starting current is moderate as the current leads only by a quadrature angle. It is having small power factor, that is during starting the power factor is between 0.2 to 0.4 due to the leading current component. It increases to nearly 0.8 at full load. It is having good efficiency, that is efficiency ranges from 75 to 85%, which is high for single phase induction motors. The applications of capacitor start induction motors are, they are used with pumps, used in water pumps and air compressors, refrigeration equipment, that is ideal for refrigerators and air conditioners. They are used with washing machines, which provides the necessary torque for the drum movement. They are used with fans and blowers, which ensures efficient operation in various ventilation systems. They are used with various machine tools like lathes, drills, and other machinery requiring high starting torque. Now next is the capacitor start capacitor run motor. The capacitor start capacitor run motor features a cage rotor with its stator comprising two windings, that is the main winding and the auxiliary winding. These windings are specially displaced by 90 electrical degrees. This motor employs two capacitors, the starting capacitor, which is utilized during startup to provide high initial torque, and the running capacitor, which is engaged for continuous operation, ensuring efficient and stable performance. Now this figure shows the diagram for the capacitor start capacitor run motor along with the actual picture of the motor. In this we can clearly see the two capacitors connected with the main and the auxiliary winding. One is the running capacitor and one is the starting capacitor. The starting capacitor is connected with a centrifugal switch. That means as soon as the rotor achieves its rated speed, the centrifugal switch gets open and the starting capacitor gets disconnected from the main winding, or we can say that the stator winding, and only the running capacitor gets connected with the stator winding. Characteristics of capacitor start, capacitor run motor. High starting or breakaway torque for easy starts under full load conditions. The improved power factor and higher efficiency due to permanent phase correction from the running capacitor. Next characteristic is the constant torque characteristic, which leads to smooth pulsation free operation. It is compact and lightweight design suitable for integration with different machine tools. It is having quiet running performance, which is useful in settings requiring low noise levels. The applications of capacitor start, capacitor run motor are they are used with pumps like different type of pumps, vane, centrifugal or gear arrangement, which is used in irrigation, water supplies, sewage, etc. These motors are used with fans and blowers in ventilation and air conditioning plants. They are used with screw compressors in refrigeration or air conditioning units. These motors are used in hoists, cranes, and elevators for frequent load handling. This type of motors are used in conveyors and material handling systems in process plants. This type of motors are also used with machine tools like lathes, mills, and drilling machines. They are used with rolling mills and processing lines in the manufacturing plants. This type of motors are also used with welding machines, grinders, mixers, and centrifugal pumps. The household applications of this motor are with washing machines, dishwashers, blenders, etc. In medical equipment like X-ray machines, ventilators, dialysis units, such type of motors are used. Now the fourth type of motor is the permanent split capacitor motor. A permanent split capacitor motor is a type of single-phase induction motor that utilizes a permanently connected capacitor to the auxiliary winding. This design helps in improving the motor's performance and efficiency. Unlike the capacitor start and capacitor run motors, the permanent split capacitor motor has only one capacitor that remains connected during both starting and running conditions. The following figure shows the circuit diagram for the permanent split capacitor motor and the actual figure or the actual picture of permanent split capacitor motor. So the characteristics of this motor are it generates moderately high starting torque for self-starting. It achieves uniform constant torque across load variations. It maintains consistent speed even under fluctuating loads. It gives high efficiency ranging from 75 to 85%. Its power factor is above 0.8 at full load. And it is having the capability for medium inertia load applications. The applications of permanent split capacitor motor in HVAC systems, which is used in air conditioners and fans due to their quiet and efficient operation. These motors are used with pumps that is suitable for water and oil pumps. These motors are used with blowers, which makes it ideal for blowers and other ventilation equipment, and they are used in copiers and other machinery requiring reliable performance. Now the next type of motor is the shaded pole induction motor. A shaded pole induction motor is a straightforward single-phase induction motor that initiates self-starting by employing a copper ring to shade one of its poles. Also referred to as a shaded ring, this copper ring functions as the motor's secondary winding. Notably, it is exclusively unidirectional and reversing its direction is not possible. This motor is characterized by high power inductance loss and a considerably low power factor. The figure shows the different parts of shaded pole motor along with the actual picture of shaded pole type of induction motor. We can see a copper ring in the pole phases connected in the alternate fashion, which acts as a secondary for the main winding. Now the characteristics of shaded pole induction motors are The speed of a shaded pole induction motor is inversely related to the number of poles employed in the motor. Shaded pole induction motors generate minimal starting torque, approximately 50% of the full load torque. These motors exhibit low efficiency due to the constant power loss in the shading coil. They are well suited for small devices that necessitate low starting torque. The rotation direction of a shaded pole motor is contingent on the shading coil's placement, which involves wrapping around half of the pole. Consequently, reversing the rotation direction is only feasible if the motor is designed to transfer the shading coil to the other half of the pole. Now let us discuss the applications of shaded pole induction motor. This type of motors are used in small household appliances such as refrigerators, fans and air purifiers. They are commonly found in commercial applications like vending machines and cooling systems for display cases. Applied in medical equipment like blood centrifuges. Used in automotive applications such as cooling fans for radiators. They are found in various HVAC systems for air circulation. They are employed in office equipment like photocopiers and printers. Next type of motor is a repulsion motor. A single phase repulsion motor consists of a stator carrying a single phase exciting winding and a rotor which has a closed type armature winding with a commutator brushes. The brushes on the commutator are short circuited. By adjusting the position of short circuited brushes on the commutator, the starting torque can be developed in the motor. This figure shows the diagram for the repulsion motor and the actual picture of the motor. The characteristics of repulsion motor are: the repulsion motor has a high starting torque and a high speed at no load. The repulsion motor has relatively low starting current and high starting torque. The speed of the motor for any given load depends upon the position of the brushes. The application of repulsion motors are in high-speed lifts, electrical locomotives, fans and pumps, printing presses, textile machines. They are also used in film winding machines, that is, for smooth manual speed and direction adjustment could be achieved without complicated circuitry. Next type of single phase motor is AC series motor. An AC series motor is a modified version of the DC series motor adapted to run on alternating current. The necessary modifications include reducing eddy currents and improving the power factor to enhance performance with AC supply. The compensating windings are used for maintaining torque and motor speed available in conductively and inductively compensated forms. The figure shows the circuit of the motor along with the actual figure. So this is the AC series motor with the compensating windings, which is called as the interpole winding and non-inductive shunt resistors. The application of AC series motors are with sieving machines, high-speed vacuum cleaner, electric showers, used in drills and power tools. Next type of motor is the universal motor. The universal motor is a unique type of motor which runs on either DC or single phase AC supply. These motors are usually series wound and produce high starting torque. So from the name itself, we can understand that the universal motor works on both AC and DC, and that is why it is called as universal motor. Hence, universal motors are built into the devices meant to drive. Universal motors operate at high speeds up to 3500 RPM. However, they run at low speed on AC supply than on DC supply of similar voltage due to a drop in reactance voltage which is seen in AC but not in DC. As we all know, there is an additional loss which is the reactance loss in AC, due to which the speed obtained for a same voltage with AC supply is less with the speed obtained for the DC supply. So a same universal motor will run at a slightly low speed for AC supply compared with the DC supply. So this figure shows the diagram for the universal motor along with the actual picture of universal motor consisting of the stator winding, the rotor shaft, the stator core, the commutator and the brushes. So by providing the compensating winding, we can use a same motor with AC as well as with the DC. The characteristics of universal motors are the universal motors have high starting torque and the speed increases with a decrease in the load. The small universal motors have significant no load losses and limit the speed to 1500 to 2000 rpm. The power factor at full load is 90% and the power factor at the beginning or overloading is low. The application of universal motor. Universal motors are simple, inexpensive and high speed type motors. These motors can function at a high speed connection to a single phase AC network. In addition, they are available in small sizes for compact domestic devices. Universal motor drive drills, electric showers, fans, wipers, sawmills, mixers, blenders, sewing machine, high-speed vacuum cleaners and machine tools. Now the next type of motor is the reluctance motor. A reluctance motor is a type of electric motor that works based on the reluctance torque produced by the reluctance force. It consists of a laminated stator and rotor similar to a synchronous motor. The key difference is that a reluctance motor does not have any windings or permanent magnets on the rotor. The rotor of a reluctance motor is usually made up of steel laminations. Since the rotor is made up of a ferromagnetic material like steel, it becomes the lowest reluctance path for the magnetic flux from the stator. The ferromagnetic materials have lower reluctance compared to air. Hence, the rotor aligns itself with the magnetic poles of the stator in the position with the least reluctance. So, this variable reluctance is used to produce torque that helps to rotate the rotor. So, in this picture, we can see the rotor is having the steel laminations only. So, which is providing the low reluctance path. In this way, a torque is produced in the reluctance motor. The characteristics of reluctance motors are, first one is the high starting torque. The reluctance motors typically produce high starting torque, making them suitable for applications requiring quick acceleration. Next characteristic is its speed control. The speed of reluctance motors can be controlled by varying the frequency of the AC supply or using advanced control techniques. Last is efficiency. These motors are known for their high efficiency, especially at higher speeds. The application of reluctance motors are with industrial automation. They are used in conveyor systems, pumps, and fans. The reluctance motors are also used with the electric vehicles. The switched reluctance motors are popular in electric vehicle propulsion systems due to their higher efficiency and robust performance. The reluctance motors are used with HVAC systems, that is, they are employed in heating, ventilation, and air conditioning systems for efficient air handling. They are also used with household appliances, that is, used in washing machines, refrigerators, and other home appliances. The reluctance motors are also used with the renewable energy, that means is applied in wind turbines and other renewable energy systems for efficient energy conversion. The next type of motor is the hysteresis motor. A hysteresis motor is a synchronous motor with a uniform air gap and without DC excitation. It operates both in single and three-phase supply. The torque in a hysteresis motor is produced due to hysteresis and eddy current induced in the rotor by the action of the rotating flux of the stator winding. Now let us discuss about the application of hysteresis motor. Hysteresis motors find their applications in instruments where accurate and precise motion control is necessary, such as record players, robotics, medical devices. They are also used in devices that require constant speed and low noise, such as clocks and timers. So, as we all know, in the robotics, a lot of motors are used in which the hysteresis motors have a major portion. Next motor is the stepper motor. A stepper motor is essentially a synchronous motor that divides a full rotation into a number of equal steps around 200 steps. That is, it is an electromechanical device which converts digital pulses into mechanical shaft rotation. It has a rotor with permanent magnets and a stator that contains winding. The winding is divided into phases, often it is two or more. Each step in stepper motor is caused by the energizing of the motor's stator winding in a particular sequence. The rotor aligns itself to the nearest stator pole. The step angle is defined as the angular rotation produced per pulse applied to the motor. A typical step angle in a stepper motor is 1.8 degrees. The speed and distance covered by the motor are directly proportional to the rate at which pulses are applied. So this figure shows the diagram of a stepper motor. In this, we can see the diagram and the actual picture of the stepper motor, which is showing the different parts, that is the rotor section, the magnets and the stator, the windings placed in the stator and the shaft. Here we can see that gear sort of arrangement is shown, which is used to move the rotor in certain steps. And as we have studied, the standard value for the rotation is 1.8 degrees. The rotation is around that degrees only. Now let us discuss the application of stepper motor. The stepper motors find its application in numerous loads. First is the CNC machines like routers, lathes, mills, 3D printers. The peripheral equipment like printers, scanners, plotters, tape drivers, and CD or DVD drives. The industrial robotics, material handling, wafer handling equipment, medical equipment like blood analyzers, imaging machine or imaging equipment, automated production machinery like labeling machines, scientific instruments like spectroscopy equipment, desktop CNC machines, laser cutters, laser engravers, CCTV camera systems for focus or zoom lens control, and lastly the radio controlled vehicles, quadcopters, cranes for positioning. The last type of motors which we are going to discuss is the servo motors, and this motors is widely used in the single phase loads. The servo motors are also called as the control motors. These motors are used in feedback control systems as output actuators and are not used for continuous energy conversion. The principle of the servo motor is similar to that of other electromagnetic motor, but the construction and operation are different. Their power rating varies from a fraction of a watt to a few hundred watts. They are the integral components of servo systems that power applications ranging from robotics to automation machinery. As we can see in different applications in robotics or home automations, various movements are required. In that, the rotational motions are provided by the servo motors, and that systems are called as the servo systems. The figure shows the different parts of servo motors and the actual picture of a servo motor. This is a very motor with a very small size, which provide the rotation according to the supply and according to the command for controlling the servo system. Now let us discuss the application of servo motor. The first application of servo motor is in industrial robotics. So in industrial robotics for controlling robotic joints and trajectory following. Let us take an example of a robot. In that we can see it is having several movement or parts which are moving in certain directions. So to control that directions, the servo motors are used. The next application is with the CNC machines. They provide precise motion control in machine tools like lathes and milling machines. As we have seen in lathe machine or the milling machines, a certain movement is required. So to control that motion in a certain direction, the servo motors are used. Next application of servo motors is in 3D printers. So in 3D printers, it controls the extruder head positional accuracy in additive manufacturing. So in 3D printers, as we have seen, it is a motion or it requires control of motion in different directions for the extruder head, so that a device is made with a 3D printer. So in that, the servo motor plays a very vital role. The next application of servo motor is with semiconductor manufacturing. In this, a critical motion requirements in lithography and inspection machines. Next application of servo motor is with automatic manufacturing. It is used in welding, painting, and assembly lines for accuracy. The next application of servo motor is in aerospace. It helps in guidance and flight control systems, wing surface positioning. Next application is with the CCTV cameras. It helps in camera positioning for surveillance applications. And at last, its application is with medical devices, that is power wheelchair motors, robotic surgery systems, etc. So in this way, we have studied the applications of different types of single phase AC motors along with the different types of three phase AC machines. So the AC machines found a very vast applications for different kinds of load. Thank you.